The next example I'm going to use here is an example we're going to go into some detail with. I like to use this example because it's, I think, a good one for college students. Number one, it also fits nicely into what I tried to teach in terms of two-factor ANOVAs and statistics. Let's pretend for just a minute or two that we're interested in looking at the impact of people drinking alcohol and taking kind of barbiturates, if you will, barbiturates or benzodiazepines. We'll just call them pills in this case, and we want to see how they might affect motor performance. So maybe we give people various levels of a product, and maybe we have them walk 100 steps on a line and see how many they can do right. Now, if you remember from the previous unit, the idea is if I define motor performance in terms of walking on a straight line, 100 steps there, that would be called an operational definition. It's a way of quantifying something called motor performance, and I'm doing it on the basis of 100 steps. So let's just say, for the sake of example, I have a couple of groups here. One are the pills group, where I have some people who are given no pills. We'll use Xanax as an example here. Xanax. Oh wait, I spelled it backwards. Ha ha ha. The other group is people getting 50 milligrams of Xanax, which is kind of a normal dose of things. I learned that after my accident. And then we have another variable, and we might call that alcohol. And in that case, we're going to use beer in the example. We'll say certain people were in the no fun group. They got no beer. Other people were randomly assigned to get beer. We'll say 72 ounces. What is that? A 6-pack of beer. So this is a 2x2 between subjects design. Everybody is only tested once. And what I do here, this is called a 2x2 factorial, because we have two independent variables, two factors. The operational definition of our DV is basically walking on a motor task, walking on a straight line, 100 steps. So in this case, if you look at the numbers there, you can tell there are 12 numbers because we have an N of 12 people. In this case, 3 people are in what I would call the no fun group. What's the no fun group? These people got no beer or no Xanax. For the 3 people that got no beer and no Xanax, as we would predict, their scores were 100, 100, and 100, so they were able to correctly walk across the white line and take 100 steps right on the white line. So that's the one group. You might actually call that a bit of a control group. So no Xanax, no beer, those 2 levels of each of those independent variables. Then you might go to the row to the right of them. The row to the right are the people, 3 more people, they got no Xanax, but they did get 72 ounces of beer. And for those people, you can see the 3 scores I've created here are 78, 80, and 82. So it looks like the beer independently kind of affected motor performance by some. Then we have the third group here. Actually, we can go back to the previous one. It might be good to put in the parentheses in that cell just what the group mean was, 78, 80, and 82. The group mean X bar would be 80. The group mean X bar for the first group, no Xanax and no beer, is 100. What about when people got no beer and they got Xanax? Well, in that particular case, the scores were 75, 80, and 85. Does it look like Xanax alone kind of affected things? Yeah, kind of caused a 20-point decrease as well. There's a little more dispersion in that group than the 78, 80, 82 group, but it looks like, once again, X bar for that group is about 80. So kind of, if you take alcohol alone, 20% reduction, take beer alone, 20% reduction. The final condition is a very interesting condition. It's where you take 3 people and kind of give them the 6-pack, the 72 ounces of beer, and you also give them 50 milligrams of Xanax. And so in that particular condition, it looks like the 3 scores for motor performance, walking on the straight line, people got only 15 steps correct, 20 and 25. So once again, if you had to get a mean for that group, the mean would be 20. Does it look like the alcohol and the pills together really affected things? Hopefully you would answer yes to that, because the score, the mean for that is 20, and that's obviously a huge effect compared to the other groups that we are talking about. One of the reasons I created this example is because one thing we know about combining benzodiazepines or barbiturates and alcohol is that's a really bad idea. If you combine them, one of the things we know is many times there's what's called a drug interaction. Now think about what that term means for just a minute. A drug interaction. That means if you just give one product or a separate product alone, you might get some simple effect. But when you combine things together, giving both alcohol and benzodiazepines, things like Xanax, when you combine them, there's what's called a drug interaction. So motor performance is very, very impacted. In fact, it's alleged that one of the reasons Marilyn Monroe died was because she was drinking alcohol and taking too many pills at the same time. So it's often called a drug interaction. So hopefully that makes sense to you. I'll stop this one now.